Alright, we have P3. Ooh. Let's see if we can make that better. There we go. Alright, section P3, we're going to start with the slope of a line, of which you should have got from the book on page 25. Fill in the blanks. Find the slope of the line that's passing through the given points. So using that slope that you find, these examples we should be able to get. Let's zoom in a little bit so we can see that. Here we go. 5 minus 4, y minus y, over x minus x. Do some simplifications. So we should have got the slope is negative 1/5. On part B, we get y minus y over x minus x. So we get 0. And we do want to simplify that to 0. Do not leave that as 0 over negative 6. And the last one, y minus y over x minus x is negative 7 over negative 3. We don't put two negatives, so we just write it as positive 7/3, and we leave that as a reduced fraction. Do not change mixed numbers. Slope is just that. It's a rise over a run, so it is not a mixed number. It is always going to be a fraction. You should be able to fill this in from the box that was given on page 26 along with the point slope formula on page 27. So using the point slope formula for this example, we're going to find the equation if we know that it goes through the xy point and has a slope of 4. So y minus y is mx minus x. Two negatives make a positive. Do some distributing. Move the 3. So we get y equals 4x minus 11. So that's our point slope formula. Alright, moving on to page 2. It says in the 1997, we had Barnes & Noble's had sales of so much with a time. In 1998, they were so much money as well. So write the linear equation giving the net sales, y, in terms of x. Alright, so we know that the time is x, the sales are y, because that's what it tells us here. Time is x, sales are y, so that tells you which ones are your x's and your y's. Now you could get a couple different answers. If we use the information that is given to us, we get our slope is y minus y over x minus x, and we get 0.2. And we get to use a decimal because it's a real world problem. Remember, with real world, we get to use decimals, word problems, but if it was just a normal one like the previous page and it came out to a fraction, we would have just left it as a fraction. Alright, so if we know the slope, then we're going to use point slope formula. I'm going to choose the second point, but it doesn't matter which one that you were to choose, and put in the point slope formula. And solve it down from there. So here we're going to distribute the negative 2 and then add over the 3. You should get y equals 0.2x minus 396.6. Now, these are kind of odd numbers to really have and to understand what their meanings are just because of the large amount of them. So one thing that you will find as you're going through the book and through word problems is that they like to make the years equal to 0, 1, 2, 3s, and so on. So if we say 1990 is actually T0, that means we would be dealing with T7 and T8. So again, when we do the slope of this, it's going to remain the same because we still get 8 minus 7 for 1, and you still have 3 minus 2.8. So the slope itself remains the same. But what happens to the equation, we're going to get y minus the y point The m is still 0.2, but in this case we're going to get x minus 8 because that's what would represent 1998. So now I'm going to get y equals 0.2x plus 1.4. So that gives me a little bit better representation or understanding of what the numbers might mean if I use this conversion. You don't have to, just know that most times in most places this is what's going to be happening. Use the equation to estimate the net sales during the year 2000. So if we use this second one, which will be the most common one, the year 2000, well, year is the x value according to our information that was given. So during the year of 2000, that would be equivalent to the year of 11. Do we know why? Make sure we understand. If this is going to be 0, 7, 8, 10. What do we got here? T equals 0 is 1990, 97, 98, so 99, and then we get year 2000. Number 10 works better. Alright, so there's the 2000. 10 is what we're going to plug in. Y equals 0.2 times 10 plus 1.4. Do some simplification with our calculators. And we get that in year 2000 it would be approximately $3.4 billion. Vocabulary, extrapolation, interpolation, slope-intercept form. To find the slope and y-intercept of each line, describe the graphs that we get here. So we're going to first solve for our y. 2y is equal to negative x plus 8. So y is equal to negative 1/2 x plus 4. We need to know that the slope is negative 1/2. The y-intercept is 4. And describe the graph. What do these things mean? It means our graph is going to begin on the y-axis at 4, and it's going to go at a slope downwards negatively 1/2. Example number 2, we're going to move the 2x and then the negative. So what does the y-intercept here and the slope-intercept of negative 2 represent? It means this is where we begin on the y-axis at negative 4. And how do we move? We move by going down to right 1 or the reverse up to left 1. But it has a negative slope and the line will decrease from left to right. Alright, your equations, you will get those from your book. Now we get to talk about parallel lines. If parallel lines, you should get from the book that they are the same. Perpendicular are if and only if slopes are negative reciprocals, page 31. One thing I do want to point out is that it is going to be that if you have a slope, the perpendicular is the negative reciprocal of that. So you can fill in the words from that from the book, but this is kind of the algebraic representation of that. So when you see it, you know that it means perpendicular slopes. For shorthand, perpendicular, we use this kind of upside down T, and for parallel, for shorthand, we use 2 slashes. Alright, so let's look at the equations of those. Find the slope-intercept equation of the line that passes through the point and is parallel to. Well, in order to use our point-slope formula, we have to know a point and we have to know a slope. This is our point. That's nice. By telling us parallel to this, we know what our slope is. Because the slope of this line, the slope is 2/3, and we want to be parallel, then we know the parallel slope is 2/3 because of definition of parallel lines. Let's look at this, what this is by a picture. What this is really saying is we have this line, 2x minus 3y equals 5, which if you were to solve for it, we're going to get y equals 2/3 x minus 5/3. So we have this line that looks something like this. And we want the line that's parallel to it, but it goes through 2, -1. So here's the 2, -1, and we want the equation of the line that's parallel going through that point. So if we know that they're parallel, we know the slope, and we know a point of the line because it was given. So now we get to use y minus y is mx minus x. Simplify this down by distributing. Subtract the 1 over, so we get y equals 2/3 x minus 7/3. Alright, so let's look at a very similar problem down here, except this time it's telling me that it's perpendicular. So again, we want the line to go through that point. This is the original line, but the line is now perpendicular. This is going to be the line that we're going to be working with. The slope of the original line is 2/3, so the slope of the perpendicular is opposite reciprocal. That's the slope of my line that I need to use in the point slope formula. We know the point. So the point is not something we had to find, it was given. The slope is what we had to find. Do some distributing. And simplify. So this is the perpendicular line. This is the parallel line. Alright, I do want to have you add in some notes. And these are actually going to be a continuation of the intercepts that it is going to start talking about. Intercepts, this is where the line crosses the x or y axis. So in order to find an x-intercept or y-intercept of an equation, we make x equal to 0, solve for y, so that will give the y-intercept. And then we make y equal to 0, solve for x, and that will give the x-intercept, because the 0 means it's going to be on the axes. That's where the point is. However, in this upcoming section, you're going to see an equation written as x over a plus y over b equal to 1. What's important here is that this does have to equal 1. But if you see something like this, A is the x-intercept. B is the y-intercept. And that concludes P3.